Here we have an exponential equation, and in this exponential equation we have to solve for x. That is, I have to find the value of x. I am saying this is an exponential equation because the variable, the equation contains variable at the exponent. So whenever we have variable at the exponent in an equation, then the equation is called exponential equation. Okay, so to solve an exponential equation, what we need to do is we have to get the same base on both sides of the equation. Once we get the same base on both sides of the equation, what we can do is the exponents can be equated and we can solve for the variable. But before that, in this equation, we need to do some simplification process. Okay, let me do it. So 9 to the power of, we have square root of x. So in my first work, what I'm going to do is I'm going to write this square root as an exponent. Whenever I write the square root as exponent, the exponent will be 1/2. And here we have square root. Again, if I write this square root as an exponent, it will become 1/2. So then we get 27 to the x to power whole to the power of 1/2. Okay, 9 to the power of x to the power of 1/2 equals to. So here we have two exponents. Here we have the base 27, and the first exponent is x. For this complete stuff, again we have the exponent. So we can use the power of a power rule in exponent. So whenever we have two exponents like this, what we can do is we can multiply the two exponents. So please understand, the second exponent is for the complete stuff. Then only you'll be able to multiply the two exponents over here. Okay, now then I'm getting 27 times. When I multiply this x and 1/2, I'm getting x over 2. So because when I multiply x and 1/2, whenever I multiply a fraction by some value, always the value has to be multiplied by the numerator alone. When I multiply this x and 1, it's just x over 2. So x times 1/2 will become just x over 2. Okay, now let's consider the base over here 9, the base over here is 27. So both of them are powers of 3. So 9 can be written as 3 square and 27 can be written as 3 to the third power, so that I will be able to get the same base on both sides. So if I try to write this 9 as a power of 3, then I'm getting 3 square whole to the power of x to the power of 1/2. And here this 27 can be written as 3 to the third power whole to the power of x over 2. Okay, again the same thing, power of a power rule, because here we have base 3 and we have exponent 2, and for this complete stuff we have this exponent x to the power of 1/2. So what we can do with these two exponents, we can multiply the two exponents over here. Then I'm getting 3 to the power of, when I multiply this one and this one, I'm getting 2 times x to the power of 1/2 equals to, here we have base 3, the first exponent is 3, and for this complete stuff I have the exponent x over 2. So what we can do is we can multiply the two exponents over here. Then I'm getting 3 to the power of, when I multiply 3 times 3 and this is x over 2, I'm getting 3x over 2. Okay, now I got the same base on both sides. So if two terms are equal with the same base, what we can do is we can equate the exponents. So when I equate the exponents, I am getting 2 times x to the power of 1/2 equals to 3x over 2. Okay, now let's get rid of this 2 over here. For that I have to multiply both sides by 2. So when I multiply both sides by 2, this 2 will cancel out. I'm getting 2 times so here 2 times 2 is 4. 4 times x to the power of 1/2 equals to 3x. Okay, now to get rid of the exponent 1/2 over here, what I need to do is I have to raise both sides of the equation to the power of 2, so that I'll be able to get rid of this exponent 1/2. The fractional exponent can be removed. Okay, let me raise both sides of the equation to the power of 2. So 4 times x to the power of 1/2 all to the power of 2, and 3x all to the power of 2. Okay, here two values are multiplied and we have the common exponent. Whenever two values are multiplied and we have a common exponent, the exponent can be taken separately for each value. When I do so, I'm getting 4 square times x to the power of 1/2 the whole square, and the same thing here 3 square times x square. Okay, in my next step, the evaluation of this 4 square is 16 times, so here we can multiply the two exponents, then I'm getting x to the power of 1/2 times 2. 3 square is 9, 9 times x square, this 2 will cancel out. So then I'm getting 16x equals to 9x square. Okay, now to solve for x, let me subtract 16x from both sides to make one of the sides of the equation as 0. So when I subtract 16x from both sides, a positive 16x, negative 16x will cancel out. Then I'm getting 0 is equal to 9x square negative 16x, or the same equation can be written as 9x square negative 16x equals to 0. So I can factor x out from these two equations. When I factor x out, so I'm getting 9x negative 16 inside the parenthesis equals to 0. So now the product of two factors equals to 0. Either the first one equals to 0 or the second one equals to 0. That is 9x negative 16 equals to 0. So now already this solved for x. That is the value of x over here is 0. Now let's solve this equation for x. So for that I have to subtract 16 from both sides. So negative 16 positive 16 will cancel. I'm getting 9x equals to 16. Okay, to solve for x, I have to divide both sides by 9. So this 9 will cancel out. Then the value we get for x over here is 16 over 9. So when I solve the given exponential equation, I'm getting two values for x. One is x equals to 0, and other one is x equals to 16/9.